Gases are volatile, not tangible, just invisible. Nevertheless, they are used in many different fields and secure the quality of our life. Medical oxygen saves lives. Helium cools magnetic resonance imaging scanners. Nitrogen is used for freezing food and ensures, in many cases, the right atmosphere. For example, for the packaging of ready-to-serve meals. Special gases are important for the production of wafers, the carriers of electronic microchips. In welding seams, gases assure good durability. Oxygen is an important assistant for the environment, for example in wastewater treatment. In addition, it helps to reduce the energy consumption in many applications, like here in steel production. The broad area of application of these all-rounders is possible because of their diverse properties. People who are informed about gases and their application are well prepared for the safe handling of the gases. In this film, you'll learn a lot about gases, from production through transportation to the applications, information and practical tips for correct handling, also in case of emergencies. For the Association of Industrial Gases, IGV, and its member companies, the protection of the man and the environment come first. This is also documented in the low accident rate in our branch as compared with other industries. Air consists of 78% nitrogen, 21% oxygen, 1% argon, and traces of other rare gases. It is precisely this mixture which makes our life on Earth possible and is the basis for many gases. But what are industrial gases? This term covers not only industrially produced gases, which are used in processes in industry and trade, but also rare gases and high-purity gases, as well as gas mixtures. Gases are divided into 4 groups according to their inherent fundamental dangers: inert, combustible, gases assisting combustion, poisonous and corrosive gases. The first group are the inert gases, for example nitrogen and argon. Inert gases are capable of displacing the air containing oxygen and can, in high concentrations, create a suffocating effect. Gases in the second group, for example oxygen and laughing gas, assist the combustion process, although they are themselves not flammable. The next group includes the flammable gases, which together with air can produce an explosive mixture. These include, in particular, acetylene, propane and hydrogen. The fourth group, containing poisonous and corrosive gases such as ammonia, fluoride and arsenic, are rarely used, so we shall not deal with the group here. Groups of gases. Inert gases, for example nitrogen and argon, danger of asphyxiation. Gases assisting combustion, for example oxygen and laughing gas, combustion accelerator. Flammable gases, for example hydrogen and propane, danger of fire. Poisonous gases, for example chlorine and carbon monoxide, danger of poisoning. At the beginning of our short test series, we will show you the liquid and solid aggregate state of gases and also some effects which can occur when gases are released in an uncontrolled manner. Superchilled and therefore liquefied nitrogen has a temperature of -196 degrees Celsius. It condenses the air to fog when transferred. If a balloon filled with carbon dioxide is immersed into the bubbling nitrogen, the carbon dioxide inside the balloon condenses below -78 degrees Celsius. It changes into a solid aggregate state, taking the form of carbon dioxide snow. Contact with superchilled cryogenic liquefied gases makes material brittle. Even a soft, flexible rubber hose turns into a frozen rock-hard material. In this state, it is so brittle that it shatters. Most gases are colorless, odorless and tasteless. Filling a container with a combustible gas, which is heavier than air, leaves such gases at the bottom of the container. This enables propane to be transferred like a liquid. The proof: no combustible gas remains in vessel 1. Instead, it is collected at the bottom of vessel 2, where it becomes a source of combustible matter. Nitrogen is an inert and not flammable gas, which displaces the oxygen contained in air from this container. The candles extinguish. For this reason, nitrogen is used to put out fires in silos and in mines. Contrary to the inert effect of nitrogen, oxygen increases the rate of burning, as shown here with a cigarette. The same applies to other materials. The specially treated cotton of a boiler suit is difficult to ignite. However, after enriching with oxygen, even this material is easily ignited. The same effect is shown on this ball of steel wool, which quickly burns with the aid of oxygen. Finally, a test using flammable gases which require our undivided attention. This balloon contains a mixture of oxygen and hydrogen. Ignition leads to immediate combustion. The result is an explosion. The ignition limits indicate the concentration of a gas in the air which is necessary for it to ignite. For acetylene, this is between 2 and 100%, and for hydrogen between 4 and 76%. The minimum flammability energy for flammable gas concentrations for acetylene and hydrogen is only 0.019 milliwatt-second. The flammability energy, which is released during an electrostatic charge between a person and the ground, is umpteen times that which is necessary to ignite gases, for example, hydrogen. Properties of gases. Most gases are color, odor, and tasteless. In some cases, fog is created by the condensation of air humidity. The volume of gases changes according to their aggregate state. There are various ways of manufacturing these gases. An important group of technical gases are the air gases nitrogen, oxygen, and argon. These are produced by separating the natural constituents of air. For this purpose, air is made liquid in an air separation plant. The necessary processes are compression, expansion, and chilling. The gases are separated in the cold box tower. The separation of the constituent parts of air is based on the different temperatures at which oxygen, argon, and nitrogen liquefy. Oxygen becomes a liquid at normal atmospheric pressure at -183 degrees Celsius, argon at -186 degrees Celsius, and nitrogen at -196 degrees Celsius. All gases produced are liquefied into a super-chilled state and stored in such specially insulated bulk storage tanks slightly above atmospheric pressure. Depending on the application and quantity required, the gases are then filled into cylinders, in a liquid state into tankers, or transferred by pipeline. Since pipelines direct to customers are generally operated by gas companies, we will concentrate here on the other methods of delivery. Industrial gases, extraction and manufacture. Nitrogen, oxygen, argon, krypton, xenon through air separation. Carbon dioxide through chemical processes and natural sources. Acetylene through reaction of calcium carbide with water, oil cracking process. Hydrogen through steam, reforming of natural gas. Helium through sourcing of special natural gas wells. Propane, a byproduct of natural gas wells. When using cryogenic gases, protective clothes must be used because the extreme cold of liquefied gases can cause injuries similar to burns. Safety glasses, protective gloves, and closed safety shoes are important. Cryogenic liquefied gases are classified as dangerous goods transport. All drivers of tankers for dangerous goods transport must be specially trained for handling and transport. Before filling commences, the driver must put up warning signs. Whilst the double-walled and vacuum-insulated storage tank is being filled, a quick closing facility prevents undue pressure beyond the acceptable limit through filling too much gas into the container. The whole filling process must be monitored by the driver. He checks the condition of the installation, records possible defects, and reports these as needing maintenance. Bulk storages. Bulk storages are regularly serviced. Scheme and operating instructions. Safety relief valves protect against excessive pressure. Handling of cryogenic liquefied gases. Full safety protection clothes. Safety gloves, safety helmet, closed safety shoes, body overalls, safety glasses. Set up warning signs. Pay attention to markings. Monitor the filling procedure. Check the installation. Like the transport of cryogenic liquefied gases, the transport of cylinder gases is classified as dangerous goods transport, and special safety precautions need to be observed. But first, we have to look at the cylinder filling operation and the distribution. To guarantee the safety of the cylinder, the cylinders are regularly and repeatedly tested. Before filling, the cylinders are checked for filling capacity and the correct labeling. The filling pressure depends on the type of gases and cylinders. The pressure range is usually 200 to 300 bar and could be up to 700 bar for special products. After filling, the tightness and temperature of the cylinders are checked. The temperature of the cylinder indicates the correct filling. The valves are closed, the connections are checked, and the safety caps screwed on if the cylinder is not equipped with a cage. For the transport of all cylinders, a valve protection is obligatory. This is also necessary for small cylinders. All cylinders have to be stored in well-ventilated areas. Important information for the handling of the different gases is contained on the label of the cylinder shoulder. This sign shows, for example, that this is a compressed gas. Apart from oxygen, all gases are asphyxiant in high concentrations. The yellow symbol indicates, in addition, that the gas assists combustion. It should be kept away from flammable material and should not be in contact with oil and grease. This gas is highly flammable and needs to be kept away from any ignition sources. This also includes any sparks from electrostatic charges. The colour of this cylinder shoulder also gives indications about the danger of the contents of the cylinder. There is a new European standard for cylinder colours. For a certain time, the new colours of the cylinder shoulder are marked with the letter N. The shoulders are marked as follows: black for nitrogen, white for oxygen. Acetylene can be identified by a brown chestnut colour. All other flammable gases are marked red, inert gases grey or green. Gas cylinders. Cylinders are retested regularly. The colour of the cylinder shoulder gives immediate information about the main properties. The dangerous goods label gives information about content and manufacturer. Handling with cylinders. Wear complete protective clothing. Pay attention to labels. Use qualified cylinders. Safeguard the cylinder. Protect the cylinder against warming above 65 degrees Celsius. The transport of gases is regulated by the Dangerous Goods Regulations for land and rail transport, and also the European Agreement ADR-RID. The vehicle must be suitable for carrying such heavy pallets. The total permissible gross laden weight of the vehicle and the maximum axle load must not be exceeded. The loading base must be able to carry at least 1.25 kilograms per square metre. Loads must be evenly distributed and secured to prevent unintentional slippage or falling over. The loader and driver are responsible for the safety of the vehicle load. All cylinders, independent of the quantity carried, must be marked. Closed loading areas must be adequately ventilated. If certain load limits are exceeded, then the driver must have training in the transportation of dangerous substances. In these cases, the orange sign identifies the load as one containing dangerous substances. The documentation, which every driver must carry, includes accident data sheet, complete and correct freight papers, fire extinguisher, warning signs, and the required protective clothing. For all participants, the transport of dangerous goods is regulated. However, exceptions for special cases are also officially regulated. For example, the ADR training certificate and carrying the accident leaflet can be exempted if only a limited amount is transported. Safety information. Transport of pressure cylinders. Notice basic requirements for filled and empty cylinders, for the lorry, for the transport documents, for the crew of the lorry, for the transport. A private person who buys a gas cylinder from the shopkeeper need not follow the dangerous goods regulations. However, they have to take necessary measures for safe transport. Companies and traders using gases are also extensively exempted from the dangerous goods regulations. But the exemption is only valid if the valve protection and the load security is in accordance with the rules, and a fire extinguisher is carried. Transport of gas cylinders. Wear protective clothing. No smoking. Open flames should not be used. Close the valve tightly and transport only with valve protection. Secure the cylinder and protect from heat. Ensure sufficient ventilation. Do not transport the cylinders with products which can ignite easily. A gas supply station, which is installed properly and regularly inspected, ensures the safe handling of gases. Also, all operating instructions for the appropriate use of the installation should be followed. It is important that valves can be opened and closed easily without the use of tools or force. Gas supply stations, which are installed by a technical company, are reliable and safe. Even then, it is necessary to test the tightness of the whole installation with a test spray for leakages, so that the gas cannot escape in an uncontrolled manner. Gas supply station. Installation by technical companies and signs, labels. Operating valves without tools. Carrying out tightness tests regularly. In spite of high safety standards and precautions, accidents cannot be totally ruled out. Therefore, it is good to know how to ensure safety in the following situations without endangering oneself or other persons. Gas equipment can develop leaks. For example, if an unsecured cylinder without valve protection falls over and the valve is damaged or opened. In this case, the first measure would be attempt to close the valve. If the gas leak cannot be stopped, but only a small amount of gas is escaping, move the bottle immediately to a safe place in the open. Ensure that you do not breathe in high gas concentrations. Cylinders of non-poisonous gases can be safely left to empty in the open. The relatively small quantity of gas which escapes does not represent any danger. If substantial quantities of gas escape, for example from a cylinder rack, disperse the gas with a jet of water. This can prevent flammable gases from being set alight. This measure is also appropriate when water-soluble gases escape, such as carbon dioxide or ammonia. The fire brigade should perform this measure. If a gas cylinder from which large quantities of gas are escaping is located inside, this exterior cylinder should be left to its own device. Open doors and windows to the outside to improve ventilation and reduce dangerous gas concentrations. All machines should, where possible, be switched off. If the escaping gas is a flammable gas, possible sources of ignition, such as open flames, should also be extinguished whilst leaving the area. However, top priority should be given to the safety of all personnel. If no further gas escapes and the area is adequately ventilated, personnel can safely return. If larger quantities of gas have escaped in a poorly ventilated area, check the gas concentration before re-entering the area, where necessary with the assistance of the local fire services. Cylinder. Leaking valve. Close valve manually or take the cylinder into the open air. High gas concentrations in closed area. When necessary, alert the fire brigade. Open doors and windows. Evacuate personnel. Switch off machines and possible sources of ignition doused. Concentration of gas should be measured again before re-entering the area. Attention! Some gases are heavier than air and collect in lower regions. Even if the gas leaving the cylinder catches fire, an attempt should first be made to close the cylinder valve. Caution! It can be extremely hot. Therefore, safety gloves should be worn for protection. If this is accomplished, the flame too will extinguish. This measure is as appropriate indoors as out. If the gas supply cannot be turned off, the fire can be put out with a fire extinguisher. However, this means that gas still escapes and could ignite again. This attempt to put out the fire should therefore not be made indoors. Here you should simply try to prevent the fire from spreading to other gases and combustible material and let the bottle burn itself out. This is also the best solution outdoors, provided the fire cannot spread. In all cases, notify the fire services. You must pay particular attention to propane and CO2, which is heavier than air, to avoid it collecting in drains and cellars. If in doubt, close off the area and inform both the fire services and the gas supplier. Where gas cylinders are close to a neighbouring fire, depending on temperature, duration and the type of gas concerned, there can be a danger of cylinders bursting. This is particularly the case with acetylene cylinders. Because of the risk of bursting cylinders, do not approach cylinders. Immediately notify the fire services and the gas supplier. Then cool the cylinders at once with water from a secure position. Continue cooling until no more water steams off the bottles. Only when this state has been reached may the bottles be transported, except for acetylene cylinders. The rule for acetylene cylinders is that they should be cooled with water and periodically tested with a distance thermometer to see whether they warm up again. If the cylinder becomes warm again, it must be cooled. The cause for this danger is possible acetylene decomposition. Continue cooling these bottles for a full 24 hours. This can be best achieved in a water bath. This may be any water basin, even an improvised one. Gas cylinders. Fire. Close the valves with safety gloves. In the open, use a fire extinguisher to put out the fire. Prevent the fire spreading. Let the container burn itself out. If necessary, cool the cylinder. Occasionally, gas equipment can develop leaks, for instance, at a connection. In this case, the technical service of the gas supplier should be informed. To deal with this fault, initially the supply must be closed and the overpressure in the equipment must be reduced. Afterwards, the leak can be fixed by lightly tightening the connection or replacing the seal. Finally, the connection should be sprayed and checked visually. Gas supply station. Leaky. Close off the gas supply. Reduce the overpressure. Mend the leak. Accidents with tankers carrying superchilled liquid gases are relatively rare. If, nevertheless, such an accident should occur, firstly, stay calm and proceed in an orderly fashion. In practice, this means securing the accident area. Then the driver should notify the police and his company.
Ja, Boss, ich stehe mit dem Tankwagen auf dem Acker. Ich brauchte mal die Feuerwehr, einen Kranwagen und einen Tankwagen zum Abpumpen. Geladen habe ich.
Apart from details of the place of accident, he should give details of any possible gas escaping or rise of pressure inside the tanker. The company concerned then takes action according to its emergency plan.
Westfalener Gehege, guten Tag. Von welcher Firma sind Sie? Wo ist der Unfall passiert? Ich werde alle Maßnahmen entsprechend einleiten. Wir haben einen Unfall gemeldet bekommen von einer Fremdfirma. Die benötigen unsere Hilfe.
Amongst other things, a tanker specialist and the nearest available and suitable tanker is sent to the accident location to enable the contents to be transferred from the accident vehicle. Here, it doesn't matter whether the assistance is the company's own or that of another gas company. Safety comes first.
In Ordnung, ich weiß Bescheid. Danke.
If the driver is in a state of shock or injured, the fire and police services should then immediately contact this company. The company's emergency number is provided on the exterior of the tanker. Information as to the material being transported is stated on the freight plate. The upper figure indicates the level of danger, and the lower one, the product.
Hallo, guten Tag. Mein Name ist Feldmann, Polizei Emstetten.
Ja.
Ist jemand verletzt?
Nein, ist nicht.
Keine Person verletzt,
Nein.
okay.
Ja.
Ja, dann wollen wir von der Straße runtergehen, damit
Ja.
wir hier nicht gefährdet sind und mal schauen, ob wir da was sehen können. Die Feuerwehr kommt ja auch schon, dann geht's ja gleich weiter.
Ja.
Hallo. Feuerwehr David.
All necessary information regarding product and relevant dangers can be obtained from the fire services control center or the gas company.
Ja, wir haben keine verletzte Person. Der Tank ist unseres Erachtens unbeschädigt. Keine Brandgefahr. Die Erkundung läuft weiterhin. Polizei ist schon vor Ort.
After the tanker and the specialist have arrived on the scene, the options of transferring the product can be checked. Where connections are accessible and no extraordinary dangers are apparent, the tanker is connected and the contents transferred. Depending on volume and product, this may take between 2 and 6 hours. The situation is quite different if the tank pressure has risen. In such cases, the pressure relief valve must be carefully opened. Depending on the position of the accident vehicle, super-chilled liquefied gas may escape. This means risk of injury through cold. If larger quantities escape, the road surface and ground may freeze. Depending on the relevant product, danger may occur through oxygen enrichment, displacement of breathing air, or fire. As soon as liquid gas is expelled, the pressure relief valve must immediately be closed again. In such circumstances, alternative valves may also be used to relieve the pressure. However, this requires a thorough knowledge of the piping system and of the product characteristics. Oxygen poses a special problem. If oxygen penetrates an asphalt surface, explosions can occur. Therefore, in the case of a tarmac-addamed road, oxygen must be diverted through a hose or the road surface covered with a suitable material. Air gases may also be drained in a controlled manner and without causing any environmental pollution.
Alles klar, zum Essen, zu.
Vielen Dank, ne?
Vielen Dank noch.
Once the tank of the broken-down vehicle is empty, a crane is normally used to right the vehicle. It is very important during recovery that only the lifting points are used on the tanker to attach appropriate lifting gear. The lifting points are identified in the recovery notices which the tanker has on board. The tanker must be thoroughly examined and all defects repaired prior to taking it back in use. Tanker recovery. Secure accident site. Caution. Danger of freezing and other properties of gas. Alert fire service and police. In case of rise in pressure, carefully open the pressure release valve. Correct recovery of tanker. Poisonous or flammable gases in cylinders need to be specially disposed of according to regulations. Special waste disposal companies may collect containers with residual content, transport, store, treat and make use of it. Residual gas disposal can be effected in various different ways. For example, through absorption of chlorine and ammonia in a wet washing process. Poisonous gases like arsenic are transformed by chemical conversion into disposable solids. Another possibility is the combustion of residual gases. These and other processes ensure a safe and ecologically harmless disposal of residual gases. The user may transport only containers which are in perfect condition. If a container is defective or the content not identifiable, the container cannot be transported.
Undefinierbarer Druckgasbehälter in Müllhaufen benötigen Entsorgungsfirma.
Gas companies have trained personnel and special rescue containers available for this case in order to transport the cylinder to the special waste disposal company. Recovery of a gas cylinder. Disposal of poisonous and flammable gases only by special waste disposal companies. Transport of containers in perfect condition always possible. Transport of defective containers or containers with unknown content is only possible by special waste disposal companies. For the Association of Industrial Gases, IGV, and the member companies' safety and the protection of man and his environment has priority. Therefore, we provide extensive information for the safe handling of gases, from specific gases safety sheets, through notes for special activities and situations, to tips for load securing for the transport of gases. You will also find a file on this DVD which you can open with a personal computer with additional information for the safe handling of gases.